Good afternoon, grade 11s. Good afternoon, educators. Welcome to our geography telematics session this afternoon, where we will be looking at how to go about preparing to answer question 3 in both paper 1 and paper 2 in the final exam. I'm also hoping that some of the grade 12 learners have joined us today, because you know that much of the map work that we do in grade 10 and 11, we carry all the way through to grade 12. So I'm hoping that there are a few grade 12 learners that will be joining us this afternoon as well. So let's have a look at what we will be doing today. Firstly, the topics that we will discuss or look at this afternoon, we will firstly look at the physical versus the cultural landscape, first of all, what the definition of physical landscape and cultural landscape is, and then also how to differentiate between the two. We will be doing a map reading throughout, and the topics that we will cover will be geomorphology, development geography, and then also resources. So these specific topics are unique to grade 11. The grade 12s do not have to know these topics, but the grade 12s that are joining us, we will also just speak very briefly about how you can incorporate this into your topics that you do this year. And then finally, we will also be looking at integration with map skills. Those are the topics that we will be looking at. And we will immediately jump into the physical versus the constructed landscapes. Now, what do we mean by physical and constructed landscapes? So as we look around our world, we see many different features. There where you are right now, if you look around, if you look through the window, or you go outside and you look around, you will see lots of different features. Some of these features occur naturally. These are things that are not made by human beings, such as rivers, mountains, trees, lakes, etc. We call these physical features. So in geography, whenever you are asked about or questioned about physical features, these are the features that we refer to. Then we have the human or human-made features, such as bridges, buildings, roads, dams, power lines, etc. These we refer to as constructed features. And here's a few photographs of 3 physical features. There's a river, there's a mountain, and there are trees. They were not made by human beings. They are physical. They are naturally occurring. Then there are 3 constructed features. There's a bridge, which was made by human beings. There's a church, which was built by human beings. And there's the wall of a dam, the actual dam itself, that was also constructed by human beings. So those are constructed features. I think you know the difference. So let's look at this photograph and see how many natural features or physical features and how many constructed features we can identify. As a matter of interest, this is a photograph of the Berg River in Paarl. So let's look at the physical landscape. There's the river. I mentioned the word river before that. So that's a physical feature or an example of the physical landscape. We can see trees, we can see a mountain in the background. Then, when it comes to constructed features, I can see a road. There's a little building on the bank of the river. There's a footbridge crossing the river. And those are 3 examples of constructed features. So grade 11s, I think that you understand that it's quite simple, right? This is not really rocket science. It's quite simple. And I think that you now know the difference between physical features on the one hand, features that occur naturally, and on the other hand, your constructed features or human-made features. Let's go on to our second topic for the day. Now, before we go on to the second topic, let's look at another example. So here's a question. Let's just say you receive this map of the Southern Cape area. You can see wilderness in the map, so we know that this is along the south coast of South Africa. So you are traveling along this national road from A to B, and you are asked to identify physical features that you can see on your journey. So you will notice that we have highlighted a few there, and we restrict ourselves to those features that occur naturally. So there's a woodland, which would be trees. There's a river. There are more trees. There's the mouth of the river, which is a physical feature. The coastline consists of coastal rocks. There is the ocean or the sea. There is a sandy beach. There is a lagoon, and there is a marsh. All of those features along that national road are physical features. And then the same question, if we are asked to identify man-made features, there's a railway line, there's a tunnel, there are buildings, there's a railway station, there's a bridge, there's a secondary road, there's a resort, and there is a other road. We could even have used the national road as well as a man-made or a human-made feature. Human-made would be a better word in this case, a human-made feature. So you understand that clearly. Now we're going to look at geomorphology and how we can incorporate, or how the examiners will incorporate the geomorphology that you learned in grade 11 into the Mapwork paper. So let's start with horizontal layers, features or landforms that result from horizontal layers of rock. And here are all those features in one photograph. So we've got the plateau, we have the escarpment, we've got the mesa, we have a butte, we have a conical hill, and a plain. So I'm not going to go into detail here. You know how these features were formed. Your teacher did that with you. You've studied it. You wrote on this in your control test in the first term already. This was probably tested again in the June exam, and it will definitely be tested again at the end of the year. So these are the features, but in addition to your question 1 of paper 1, where you can be tested on this work can also come into question 3 in paper 1, where your geomorphology can once again be tested. So let's have a look. So on this map, I have indicated 3 features. A conical hill, that is the drawing over here. Here is, let me just put my laser pointer on. So over here we have the sketch of a conical hill. This is what a conical hill looks like. And on the map, this is what we are going to see. Let's have a look closely. So as I'm moving from west to east, from your left to right, from west to east, notice there's a steep slope going up. You get to the point top of the hill, the apex, and then there's a steep slope going down. So watch here. There's the steep slope. How do I know this steep slope here? There it is. How do I know the slope is steep? The contour lines are very close together. So I move up the steep slope to the apex. That's the top there. There it is. And there it is. You can see the trig beacon shows me the top. So up the steep slope to the top, and then down the steep slope on the other side, and that is my conical hill. And this is what a cross section through that conical hill will look like. Over here I have a butte, similar to the conical hill, steep slope going up, but then a small flat surface at the top and a steep slope on the other side. And here we have it. Contour lines are close, indicating the steep slope. Then there are contour lines that are slightly further spaced apart, which shows me this flat top of the butte, and then the steep slope down again on the other side. And that is my butte. For a mesa, we have a steep slope going up, and I can see the steep slope going up on the side. Then there is a flat tabletop before I get a steep slope going down on the other side. So my contour lines are close, indicating the steep slope up. Contour lines far apart here, showing the flat tabletop, and then the steep slope down on the other side as well, giving me the mesa. So grade 11s, you must be able to identify these features not only by means of a sketch, but also on a topographical map. And you need to use the contour line showing you the steep slopes and showing you the flat section at the top. So make sure, ask your teachers to give you maps. If you don't have a map accessible, go onto your cell phones or onto your laptops, Google topographical map showing Mesa topographical map showing Butte, whatever the case might be, and you'll be able to see these features and be prepared to be able to identify them in your Mapwork question at the end of the year. Let's go back to our presentation to see what's up next. On the map, you can then also be asked to integrate map skills. So you could be tested on Mises, Buttes, etc., and at the same time be asked to use certain skills. And in this case, on that same map, I'm asking you to determine the bearing from the trig beacon on the conical hill to the trig beacon on top of the mesa. So you know, there's the trig beacon, and I drew, the first step I drew my line, my very straight line in a northerly direction. Then I drew another line joining the two. So here is the trig beacon on the conical hill. Remember we worked with this conical hill. So I drew my line to the north, and there's the trig beacon on top of the mesa, and I drew my line from that one to that one, a straight line, joining it. Now remember, now we put down a protractor. Notice the position of the protractor. We can't have 90 at the top. At the top there, I don't have the entire protractor on here, but you know that 0 is in that direction, and we're going to measure in this direction. We're going to measure from 0 in that direction. And I can see the measurements there, 60, 70, 80, 90, and it is 150 something. Because there's 140, there's 150, there's 160, so it's going to be 153 or 154, something to that effect, okay? And I get 154 degrees. So this is a map skill that we need to know, and it was tested in exactly the same question while testing the landforms resulting from horizontal strata. Now, you also learned in term 1 about inclined strata. I'm not going to spend too much time, but you need to know what inclined strata is. If you just look at the top heading there, what is it? It's layers of rock below the Earth's surface which tilt at an angle. How was it formed? By tectonic forces, right? The same forces that cause earthquakes to occur. And hard and soft layers of rock are eventually exposed at the surface. Where is it found? Notice the questions geographers ask. Your teacher would have done this with you before. Large areas. It's found across the country because large areas of South Africa have tilted or inclined sedimentary rock. A classic example is the Magaliesberg, and on the following page, on the following slide, I'm going to show you examples of this. Why are there different types of inclined layers or homoclinal ridges, as we call them, and what do they look like? We get cuestas. There are 3 types. We get cuestas, where the inclined strata dip between 10 degrees and 25 degrees, and that's a relatively gradual dip, okay? And when we speak about dip, here is my inclined layer. That is the horizontal. This doesn't exist. This is just a horizontal line, and from that horizontal line to my inclined layer, I get an angle of 10 to 25 degrees. If that inclined angle increases, so here is my inclined layer now, and if that angle from the horizontal is between 25 and 45 degrees, I now don't call it a cuesta any longer, I call it a homoclinal ridge. And if that incline is even steeper from the horizontal to my inclined layer is greater than 45 degrees, then I call it a hogsback ridge. So grade 11s, in other words, your cuesta, your homoclinal ridge, your hogsback ridge, they're the same thing. The only difference is the angle between this layer and the horizontal. And depending on the angle, it gets a different name. Okay, so you know the landforms. We've already spoken about the cuesta, the homoclinal ridge, and the hogsback ridge. And then cuestas can either form in a basin or in a dome shape, and you need to be able to identify this. Once again, I'm not going to go into detail. We are not busy teaching this work now. I'm just busy explaining to you which of the theory that you had done in the classroom could be tested in your Mapwork exam. And then you also need to know how to manage the impact of these landscapes. So in other words, Your harder layers will have less fertile soil, so there's not going to be as much farming activity taking place there. Slopes may be suitable for forestry. Cuestas are usually low, so there are no traffic obstacles. So you've learned about the cuesta around the basin around France, for example, around Paris in France. So there's no traffic obstacles. It's easy to build roads over them, and they can also trap. Your cuesta basins can trap underground water and oil, and often when mining for oil, your geologists will look for cuesta basins because that is often where they are found. Right, so that is what you need to bear in mind when you are studying the section, and it can be asked in your Mapwork paper. So let's have a look at this map. What do I have here? I have a steep slope on the one side, the top, and then a gradual slope on the other side. Here is an inclined layer. Okay? So which one of these diagrams represents a cross-section from A to B? Now watch. As I move from A to B, I'm getting a steep slope going up, a short steep slope, and then a longer gradual slope on this side. Can it be diagram number 1? No. Because here, when I'm moving from A, I'm getting a long gradual slope and then the steep slope. So it's not this. When I look at number 2, it definitely isn't this, because number 2 has steep, flat, steep down, steep up, flat, steep down. And that's definitely not the case. But when I look at number 3, when I look at diagram 3, from A, there's a steep slope up to the apex and then a gradual slope down. And look at here, steep slope up, gradual slope down, so it is definitely number 3. So diagram number 3 will represent the cross-section from A to B. Okay. And when I look at this topographic map of the Magaliesberg, there I can see, notice the steeper slope on the side, which is known as the scarp slope, where the contours are close. See there how close the contours are? So that is called the scarp slope of my homoclinal ridge. And on this side, my contour lines are further apart. It's a more gentle slope known as the dip slope. And we identify these gradients by means of the contours. So when you have a homoclinal ridge, your steeper slope is called the scarp slope. I identify it by seeing how close my contour lines are together. And on the other side, I have the dip slope, which I can identify by the contours being further apart. And this tells me that this is the dip slope, which is a more gentle slope. Right. Here is a photograph. Here is a photograph of exactly the same area. And I can see on the side the steepness of the slope. Let's take the side here. The steepness of the slope here and the gentleness of the slope on the other side. Here the slope is up steep. Look at this. Steep, steep, steep. There's vegetation growing on the slope, but here's my steep slope, and there's my more gentle slope. Can you see that? Steep going up, contour lines close together. Gentle slope going down, contour lines further apart. So here is a photograph, an aerial photograph of exactly the same area in the Magaliesberg. Right. Now, grade 11s, you know that you have also looked at landforms that result from volcanic activity, especially internal volcanism, intrusive volcanism, where your magma has cooled and solidified within the Earth's crust. And your teacher would have taught you how the different landforms, what they are, your batholith and your laccolith and your lopolith, your sill, your dike, etc. So you should know the names of the different landforms. You should be able to identify them in a diagram. You should be able to explain how they are formed. But once again, this work can be tested in the Mapwork question. Question 3 of paper 1. This work can be tested again. So let's go and have a look at how to identify these landforms, these features on a map. Let's go and have a look. So, first of all, here is what they look like in a diagram. A batholith, the large mass of magma that is cooled. This diagram should be familiar to you. The laccolith, which I've spelt incorrectly, it should have 2 C's, sorry for that. The lopolith, which is the one that looks like a saucer or a basin. The laccolith is the one that looks like a mushroom. There's a volcano or volcanic cone, volcanic crater. and then there's a sill and a dike. Now, on the map, here's an example from Paul, and I see a picture of Paul Rock. And we know that Paul Rock is a granite dome. The indigenous people of the area, the Khoi people who lived in the area, used to call it Tortoise Mountain because it looks like a tortoise. And Paul Rock can also be identified on a map. On the topographical map, we can see there the various other rocks which make up Paul Rock, such as Gordon's Rock, etc. So, how can this be asked in a Mapwork paper when it comes to using your skills? And the skill that comes to mind here is intervisibility. In other words, where you need to be able to explain if one point is visible from another. So let's take this line here that you see on the map. You see on the right hand side or on the western side the school building, and then on the left hand side you see Paul Rock. Now, you see that there? There's Paul Rock. The school is over here. So let me just show you. There's the school. There is that building is the school building. That shows me the school. And this is Paul Rock. You can see there in Afrikaans is written Parel Rots. Okay, and there's the top of Paul Rock. The school is at an altitude of 180 meters above sea level. Paul Rock is 543,1. If I look inside here, I'll see 543,1 meters above sea level. Here are contour lines indicating the 200 meter contour, the 300 and the 400. So my slope is going up in this direction. And can I see Paul Rock from the school? And the answer, what do you think it's going to be? It's going to be yes, obviously, because Paul Rock is higher than the school. And as you can see, there's nothing in the way. There's no mountain or building or any feature in the way that's going to block your view of Paul Rock. So the learners at this particular school, if they glance in more or less a westerly direction, just south of west, a westerly direction, they will quite easily see Paul Rock because there are no features blocking the way. So there is intervisibility between the school and Paul Rock. Paul Rock is visible from the school. However, if we look at Gordon's Rock, which is over here, can learners at this school, if they look in this direction, can they see Gordon's Rock? Now, Gordon's Rock is at an altitude of 600 meters. Sorry, no, it's not. It's not. Let's just go one step further. There's Gordon's Rock. Oh, sorry. The question is, I'm getting this wrong. The question is, can the Nantes Dam be seen from the school? Sorry, I was just a bit confused there. The question is, can the Nantes Dam be seen from the school? So there's the school, there's the Nantes Dam, and the answer is obviously not, because Gordon Rock over here is 654 meters above sea level. And Gordon's Rock here, lies between the school and the Nantes Dam. And here we can see it clearly. So any learner standing at the school can see Paul Rock, they can see Gordon's Rock, but they cannot see the Nantes Dam because Gordon's Rock is in the way. So there's no intervisibility. You cannot see the Nantes Dam from the school. Okay? Neither can, if you're standing at the dam, you cannot see Paul Rock either. So a learner standing at the school cannot see the dam because Gordon's Rock is in the way, and anybody at the dam busy having a braai or swimming, whatever, cannot see Paul Rock because Gordon's Rock is in the way. There's no intervisibility in both directions, either from the school to the dam or from the dam in that direction, because of this higher feature in the way. And if we look over there, there's a picture of Gordon's Rock. Here's the Nantes Dam. I'm at the dam. I'm having a nice swim because the weather's getting so much nicer now as we're moving towards summer. Spring has established itself. We're out of the winter months. So many people will be going to their dam to swim or to have a braai or a picnic. And when they are there, they cannot see Paul Rock or the school in the distance, because Gordon's Rock is blocking their view. It is in your line of vision. So there is no intervisibility from the dam in the opposite direction. And here's an aerial view. There's Paul Rock at the height of 543. There's Gordon's Rock at the height of 654 meters. And there's the Nantes Dam, which is at 600 meters. So the Gordon's Rock trumps them all. It is much higher. Anybody here can't see Paul Rock, and anybody at Paul Rock can't see the dam also. Okay, I think you are quite clear on what intervisibility is. If you didn't understand it before now, I think that now you do understand what we mean by intervisibility. Right, Paul Rock is not intervisible from Nantes Dam. We've established that well and truly, so let's move on. Now, grade 11s, you also do a section on development geography in grade 11. So the grade 12s that are with us, you don't have to know this. But you, grade 12s, have to be able to incorporate settlement geography and your your rural and urban settlement and your section on the economy of South Africa into your Mapwork section. But this particular telematics broadcast is for the grade 11s. So the grade 12s, just bear with us at this stage. I know that you're writing very soon. I know that you're eager to score the marks. But bear with us because we're focusing on grade 11 work. But while I'm going through this, grade 12s, think of rural, urban settlement, South African economic, possible questions that you think could be asked in Mapwork. So grade 11s, let's have a look at what we're doing in development geography. So we look at levels of development. Okay, so in South Africa, we have different levels of development. And here is a topographic map and a satellite image of the same area in the Strand here in the Western Cape. Now, when I look at this area here, and when I look at that area on the other side, I see distinct differences between this area and that area over there. And if I look at the aerial photograph, it becomes much more evident. Here I see lots of greenery. Look at this. Look at this here. I see an irregular street pattern. I see larger plots, bigger houses. But here I'm looking at very, very high density. Very, very high density buildings, smaller buildings. So this is obviously a higher income area over there, and that's obviously a lower income area over there. And when I look over here, I can see it even better. Look at the houses here. Each house is on its own plot. Look at the size. Here I can see the roof of this house. Here I can see the roof of this house. Big houses. And just on the other side of the fence, look at this high density buildings. Tiny houses closer together. Can you see that here the roads are tarred? And I can quite clearly see on this photograph that these roads are not tarred. So I can see that this here is a low income area. High building density, smaller buildings closer to each other. Here the buildings are spread further apart. I can see swimming pools in people's yards. There's a swimming pool, there's a swimming pool, there's another one. I can see how broad the roads are. I can see lots of trees, lawns. Look at this greenery here, which I do not have over here. And all of this tells me that this is a high income area, much higher level of development. And here is a low income residential area with lower levels of development. Then we also look at resources and sustainability in grade 11. Very interesting topic. And one of the first things that you looked at there, grade 11s, was soil erosion. And you need to know the definition of soil erosion. You can be asked to define soil erosion. It occurs when the top layer of soil is removed from the land by one of the agents of erosion, such as water, wind, or ice. We need to know the strategies, and you can be asked this even in your Mapwork question, the strategies to combat soil erosion. So, how do we prevent the loss of soil? By building retaining walls. There's a retaining wall. And any soil, I can see another strategy there, that the soil is covered with vegetation. Notice the green vegetation covering the soil, which prevents the soil from being lost. But even if that vegetation wasn't there and the wind were to blow that soil, for example, the retaining wall would block a lot of the soil and prevent it from being blown away. When we do our plowing. Notice how nicely this farmer has plowed all along the contour lines, because contour plowing prevents water from running down the slope and therefore washing away the soil. And we can identify retaining walls and contour plowing on a topographical map. Reducing of livestock. This will prevent overgrazing. It is difficult to see on a topographical map when livestock has been reduced, but it is one way in which we do combat soil erosion by having less animals on our farm. We can rotate the crops to preserve nutrients in the soil, because different types of crops, certain crops, for example, like beans, or what we call nitrogen fixing plants. So when we plant beans, they put nutrients back into the soil like nitrogen, and in the following year you can grow wheat or maize or something that uses up the nitrogen again, and in that way we keep the soil fertile and we prevent soil erosion from taking place. And then another strategy would be to build windbreaks. There we can see we planted rows of trees to break the wind, and if the speed of the wind is broken, it will reduce wind erosion. And also just planting trees generally, not just rows of trees, but just trees in general, and that will also protect the soil from being eroded. And of these, I can see a retaining wall on the map, contour plowing I can see on the map, rows of trees I could see on the map, and just individual trees as well. So 4 of these 6 mechanisms to reduce soil erosion you should be able to identify on a topographical map. Now, rows of trees, this question grade 12s you need to know as well, but grade 11s, and even if there are grade 10s listening, you will be asked what the function of a row of trees are. So the examiner can sort of direct your attention, say, to this row of trees over here, or this row of trees over here, or to any of the rows of trees on this map. I can see lots and lots of rows of trees on this particular map, and you can be asked what is the function of these rows of trees. And I was stuttering when I typed this rows of trees. Said it twice. Right, firstly, trees play the role of a windbreak. They slow the wind down, and that will significantly help to reduce erosion. Okay? Trees can also be used as farm boundaries. Often, between one farm and the next, the farmers will plant rows of trees so that they have an indication of where the one farm stops and where the next farm starts. So the rows of trees are usually planted along farm boundaries, just to help farmers to see, where does my property, where does my farm end, and where does the next farm start. So we just plant rows of trees along the boundary. And then the last one is the aesthetic value. In other words, you know, the minute you see the word aesthetic, you think about the visual component, how pretty or how nice it looks. So the rows of trees also have an aesthetic value. They add an aesthetic value to an area. They make an area look much nicer than what it really is. So those are the 4 ways in which, or the 4 reasons why we can plant trees: to act as windbreaks, to reduce erosion, as a farm boundary to show us where one farm ends and the next one starts, and also just to make the area look a little bit more beautiful, to beautify an area. Contour plowing, this is how we can identify it. You can see there the crops, your vegetation which was planted, and we can see that planting has taken place along, especially in the photograph, in the aerial photograph, we can see that planting has taken place along the contours. And in order to achieve this, the farmer had to plow along the contour line. Right. Grade 11s, let's move on to our next topic. And you know that we look in grade 11 at energy sources, and we compare conventional energy sources or traditional energy sources such as coal and nuclear. Right. In the past, nuclear used to be seen as a alternate source of energy, but it's so commonly used nowadays that it has become a conventional source of energy. Okay? And here's a map showing the Magdalene area in Witbank. It used to be called Witbank. It's a city on the high veld of Mpumalanga, sort of halfway between Johannesburg and Nelspruit. The city is known for coal mining in the surrounding region. It has grown rapidly around heavy industry. Why would there be heavy industry situated here? Because of the coal. You know that coal is used to generate electricity, and heavy industries require huge amounts of electricity. So in the area surrounding Witbank in Mpumalanga, we find that lots of coal is mined there, and therefore it's logical that a lot of heavy industries will be found there. We also know that iron ore is available from relatively close by, and iron ore plus coal is a good recipe for heavy industries to be established. So that is why there are so many heavy industries in this area. So let's go back and have a look further at this map. And on the map, I could ask you, for example, which primary activity takes place here and give reasons why. So how do I know? There is an example of an open cast mine. Okay, here it is, it's on the map. Here is an excavation. An excavation means that the ground is being dug up, it's being excavated. There is a colliery. A colliery is a coal mine. It says there colliery, there's an excavation with a colliery. So this coal is being dug out. And remember, your coal mines are open cast mines, so there will be diggings or excavations. There's a slimes dam. Slimes dams are dams that are used to capture the water that is used in the mining process. So if you see a slimes dam, you know for a fact that mining is taking place. It says here that the ground is subsiding. That is a side effect, to use that term, of the mining process. Because we're busy digging up, the ground becomes unstable and it often subsides. Similarly, sinkholes. Here's just a large area that is subsiding, and here are specific holes, areas, smaller areas where the ground is busy sinking, and we call those sinkholes. And there is a mine dump. Okay, so this, all of these, all 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8 features here show us that mining is taking place in this particular area, and the type of mine is specifically a coal mine or a colliery. When it comes to thermal power stations, we can see a power station. Here's the Kriel power station. Here's the buildings of the power station. Here we can see it in the photograph. There we can see it on the map. Okay, so how do we identify a power station? We can see it is typed in the power station. There's the conveyor belts. The conveyor belts usually bring the coal. Because remember, with your thermal power station, coal is burnt, and these power stations are built close to the mines. So conveyor belts, there's the conveyor belt running, and the conveyor belt, there's the slimes dam of the mine. The conveyor belt will carry the coal to the actual power station here where the coal is burnt. Okay, there's the power lines here. Here are the power lines which is taking the electricity away from the power station to the towns and cities where they are going to be used either for domestic use or for industries or whatever the case might be. Nuclear energy. Here is a photograph of the Koeberg nuclear power station out here in the Western Cape. Usually you will get a case study and you can be asked about advantages and disadvantages. That is how the nuclear energy section will be tested. So here is a picture of, a map and a picture of Koeberg. Koeberg is the only nuclear station in South Africa, in Africa for that matter. Grade 11s, please try to get your parents, if you live in the Western Cape, which most of you do that I'm speaking to now, get your parents. I drove past there last week. Entrance to the Koeberg nuclear power station is free. There's a nature reserve around. You can go mountain biking, you can go walking. There's a lot. If you arrange beforehand, you could even get someone to go and show you the functioning of the nuclear power station. Go and have a look. It's very, very interesting. Okay? And it's right here in the Western Cape, and it's not going to cost you a cent to go and have a look. So it's the only nuclear power station in Africa. It's got the largest turbine generators in the southern hemisphere, mostly it is the most southerly situated nuclear power station in the world. There's no nuclear power station in the world further south than Koeberg. It gives us in the Western Cape a reliable supply of electricity. And even though we do also experience load shedding, we experience load shedding to a lesser degree than other provinces because of the Koeberg nuclear power station that supplements our electricity. and it ranks amongst the safest nuclear power stations in the world. It is also the most reliable of all the Eskom power stations. Our Koeberg nuclear power station is the most reliable one. It is far more reliable than the coal-burning ones that we find in the interior of South Africa. Non-conventional energy sources, we're coming close to the end of our presentation. So these are new and alternative. They're usually cleaner forms of electricity, such as wind generated and solar. How do we recognize them? First of all, you must know this content. You must know what non-conventional energy sources are. You must be able to give examples such as wind turbines, etc. What is the future of non-conventional energy in South Africa? Your teacher has taught you this. What are the effects of non-conventional energy sources on the economy and on the environment? So please make sure that you know this content that you've been taught in the classroom. Here's a wind farm. How do I know? Firstly, there's power lines. See that? There's the power lines running from the center. There's usually turbines. So here's the Gouda wind farm, just outside the town of Gouda in the Western Cape province. It is capable of powering 200,000 households per year, or 400 gigawatt hours of electricity. Each of the turbine blades, the 3 blades, are 50 meters in length. People, if you live in the Western Cape, take a drive out, go to Gouda, go to, there are lots of places along the West Coast that have, just Google it, see where there are turbines. Your Caledon area, as you drive towards Caledon, and then from Caledon out to Bredasdorp, there's a lot of these turbines. Get your parents to take you there, ask your teacher to arrange something. It's so nice to see them. And these pictures that you see on the screen in front of you don't do justice to them. These things are huge. Each of those blades are 50 meters long. When you run 100 meters in the athletics, if you put 2 of those blades together next to each other, that will be 100 meters. These things are huge. They are massive. So when the wind is blowing, they generate a lot of electricity. Those concrete towers are 100 meters high that they are mounted on. So that gives you some idea of the size of these turbines. There's a wind farm in Gqeberha, and there's a new map symbol. Look at the map symbol there for wind turbine or wind farm. There's the symbol. Older maps that are older than 2 or 3 years old will not have these symbols on, because these wind turbines did not exist. So this wind pump here, which is like an X with a line, this is what we would call a windmill back in the day. Now grade 11, let me just teach you something. See here, wind pump, semicolon, monument. Here are two. Tomorrow Mr. Malan will focus on this side and he will say windpomp, monument. Now, when you have 2 symbols on your map, on the key of the map, the first word here refers to the first symbol. The second word refers to the second symbol. This does not mean that symbol there is for a wind pump and a monument, and that symbol there is for a wind pump and a monument. Icona. There are 2 symbols, there are 2 descriptors, and the first descriptor describes the first symbol, the second descriptor describes the second symbol. So here, for example, you've got a wind turbine, wind farm. So this one is the wind turbine, and because there are many wind turbines together, it's called the wind farm. Okay? Satellite antenna, solar panel array. Also new. A satellite antenna would look like that, where you basically use it for what do we call this, Wi-Fi, for getting the internet to people in remote areas. And this is an array of solar panels. That is what it will look like on the map. Here's the Kuga wind farm. There's my symbols. You see that? Okay. So these are all new things, and this is on the map of Gqeberha. Grade 12s, we've come to the, sorry, grade 11s, we've come to the end of our presentation this afternoon. The grade 12s and grade 10s that have joined us, thank you for coming as well. We've looked at quite a bit and we've gone through it very, very hurriedly. But I think you now have a better idea of what you can expect other than your usual Mapwork questions like calculations, etc. But what you can expect based on the grade 11 work in your final Mapwork paper of paper 1. Remember, paper 1 has a Mapwork component to it, as does paper 2. But because the topics that we looked at here today, the first lot of topics, the climate, the geomorph especially, that you will find in the Mapwork of your paper 1. Whereas the things towards the end, these alternative forms of energy and development, the different levels of development, that you will find in the Mapwork question 3 of paper 2. Okay? So whatever was tested in the theory of paper 1 could apply in the Mapwork of paper 1. And whatever was tested in the theory of paper 2 could be applied in the Mapwork of paper 2. So grade 11's, best of luck. This will be our last geography broadcast in telematics for the year and until next year. So to all the educators, thank you so much for persevering, for sticking it out this year, for staying in the afternoons after school, for making sure that your learners get the links to these broadcasts. It really means a lot to us that you are putting so much into it. So those of you that still have to travel home, travel safely, walk home safely, public transport, whichever way you're getting home, get home safely. Please study hard so that we all do well in our geography. So thank you to the learners and to the educators for being here with us. Thank you so much for joining us. Good afternoon.